Hi, I'm Douglas Jones, and this is my presentation for my ARENA simulation for Project A of Manufacturing Systems Model. Here's a quick overview of my system. I will start off with starting with the incoming patients block. Got to zoom in a picture here. So we first start off with a create block, which creates the patient entities. They then enter a pretty complicated assign model. I will run you through what that looks like now. So I'll run you through each one individually. The first one sets an attribute which records the time that it entered the system. So this is for some recording later on. This is the important one, the checkout plan. It is assigned with this discrete probabilities function. There's a 50% chance it will be assigned to the value 1. A 30% chance it will be assigned to the value 2. For 15% chance it will be assigned to 3. And then finally the last 5% that it will be assigned to 4. So these numbers correspond to the first, second, and third checkup plans. Numbers 3 and 4 are both third checkup plan, just the different ages of the patients. So with these values for the checkup plan, I assign appropriate pictures for each, old and young looking patients, and the ones that are with the third plan or the drug testing plan, I've just added a little pill system above the shoulder, just to distinguish them. Then finally, I assign their sequence, which tells them what stations to go to. I'll go through that later on. Back to the presentation. So then it quickly goes through a decision block, which separates them into young and old patients, where I can assign the walking speeds. In these assigned blocks, we've got a uniform distribution. The young ones are faster than the old ones, as specified in the project instructions. And again, as specified in the project instructions, this is an attribute assigned to the patients themselves, and they keep it throughout the system, this particular speed. Then they go through a station. This serves no code purpose, it's just for animation. And then they go into this root block to actually start going through the system. How they decide where to go in the system is through my sequencing. Using the sequence function of ARENA, I have laid out 4 different sequences. 3 and 4 are pretty much the same, just for the young and old parts of the third plan. As an example, I've shown you the steps for the Plan 1 sequence, where first it goes into the physical exam, then the x-ray, then the blood sampling, then the medical consultation, and then they exit the clinic. For each of these steps, I assigned an attribute which says the distance the patient has to walk to get to where they're going. So this was found using this diagram, which was provided in the project description. The only thing worth mentioning with the distances is for some ones where they skip over some stations to go to the next ones, like for example the drug testing checkup plan goes straight to the blood, skips over the physical exam and x-ray. Had to add up the distances. So the first one, they've got to walk 62 meters, for example. Presentation. Okay, finally we get to the meat of it, where the patients are processed in their checkups. According to the sequences assigned to them in that first assign block, they enter one of the stations for each of the rooms. I should show you what the root blocks look like. They're all the same, so the destination type is by sequence, so they look at the sequence assigned to each patient entity to decide where to go. And then the route time is distance applied to the step that in the sequence that I showed before, divided by that particular patient's walking speed. So as an example, I will quickly show you the physical exam room process, because most of them look pretty similar. So in this one, it's a seize, delay, release, and it uses the one resource of a nurse. Now, most of them only have the one resource, which is a nurse per room. And the delay time is triangular. These are the numbers used. They are all specified in the project description. Now, the only one that's particularly different is the urine and stool sampling room, where instead of just the one resource, we have got 8. We've got a set of 8 toilets. For this, I made a set using the set function of arena. I'll show you what that looks like. In here, I've just got a table with 8 toilets in it. I did that for good animation, which you'll see later. Back to the presentation. So once they go through all this, they finally enter the medical consultation room. All of them end here. And after they finish the consultation, they go to the clinic exit station. Here they're split up with a decision block into what plans they signed up for. So Plan 1, Plan 2, and Plan 3. The assigned values of 3 and 4 both go through here. And these record blocks, they record the time that each patient spent in the system by checking that start time attribute I assigned at the very start and comparing with the current simulation time. And that's tallied, so I can check the results later. I can see that. And finally, the patient leaves the system and the entity is destroyed. Finally, to mention with the code is the cutoff system. Here we have a create block which creates just one cutoff entity at the end of the time of the simulation, which is 8 hours. When it enters this assign module, it changes the variables that tell the create block that creates the patients how many to make. So it just tells it not to make any more, and then finally disposes of that entity. So what this does is it just, after 8 hours have passed in this simulation, it makes no more patients to enter the system. So this is so that instead of just the simulation ending after 8 hours, it will flush out the rest of the patients still in the system instead of just booting them out. The only other change to be noted is inside the run parameters, the replication parameters. At the terminating condition, I've got this set of code where the simulation terminates after 8 hours have passed and after no patients are left in the system. That's what that entity's work in progress patient equals 0 means. Finally, we'll get to the fun bit, the animation. So for the animation, I used lots of station and route blocks. The routes represent every possible route that the patient can take. So there's one that runs straight from the start to blood sampling. For example, for the drug testing patients. And I'll now show you what that looks like. Go over here, and I'll slow it down so you can see. So the red shirts are the young patients. You can see there's that guy with the pill on his shoulder. They're the drug testers. For whatever reason, it kind of takes a while for older people to start entering the system. They're wearing blue. They eventually show up. There's one just entered the physical exam room. So you can see all the patients are moving at different speeds because they're assigned random walking speeds. You can also see the urine and stool sampling. The toilets are occupied randomly. Yeah, I think you got the gist of that, so I'll fast forward to the results. So here we find that 97 patients went through the system. If I go through here, I can see the times that each type of patient were in the system for. We'll look at averages. So for the first checkup plan, it was around 31 minutes average. For the second, it was 44. And for the third, the shortest, it was 23. And I was expecting numbers like this, so this looks good. Okay, that's all I got for you. Thank you so much for listening.